Today is the lecture that is on solar photovoltaic. So we will study that how solar energy is available in a particular site and how much amount is available in a particular site and how that we can convert that solar energy into an electricity. So first of all, this is the subject that is non-conventional energy sources, and in this non-conventional energy sources, we have solar photovoltaic. So OEI second of all, lecture number 3. First of all, we should know that what is solar. It originates with the thermonuclear fusion reaction occurring in the sun, and it replaces the entire electromagnetic radiation. So the energy that is received on the Earth's surface that is about most of the solar energy that we can convert into electricity. So the sun energy, that is the solar energy, 19% of it is absorbed by the vapor, ocean dust, etc. 8% gets dispersed in the atmosphere itself, and 17% of it is reflected by the clouds, and 4% is absorbed by the clouds, whereas 6% of the energy is reflected by the Earth's surface. Rest of the energy, that is 46% of the energy, that is absorbed by the Earth. So here we have the solar photovoltaic, in where we have solar cells, which in turn is connected in series and in parallel to form solar photovoltaic panels, which convert the light energy to electricity. So this is a particular pattern, solar panel, and many such panels are converted, is connected in series and parallel form to make a solar PV array. So what are the main applications? Generally, there are different types of applications. It can be on-grid applications or off-grid applications. So generally, the different types of solar photovoltaic energy that is used in water pumping system for agriculture, in space technology, and for rural home systems. Solar home systems are available for some telecom applications are there. So different main applications are with the grid connected systems, where we can have commercial buildings up to 50 kilowatt of solar panels to be installed on the rooftop, so that we can generate the electricity consumed by that particular building, as well as the excess energy that can be put onto the grid. Similarly, the residential home system comes in lower values of kilowatt, that is from 2 to 8 kilowatt, and the PV power plants generally it is more than 100 kilowatt. So NTPC Rajgarh we have over 50 megawatt plant is there. There is a view, you can see the view that how large is this particular plant and what could be the capacity of generating electricity from this plant. So the photovoltaic use semiconductor materials to convert the sunlight into electricity. As long as solar cell is exposed to photons with energies above the bandgap energy, the whole electron hole pairs that have been created, the problem in electrons can fall back into the hole recombination, causing both charge carriers to disappear. In PV, avoiding the problem by creating electric field within the semiconductor itself that pushes the electron in one direction and holds it another. So this comes with the modeling of the PV cell. So we can say that this is a PV cell which generates current, and it is served to a particular load which has an equivalent model of this one. This is a current source in parallel with a diode, and then this is a simple basic equivalent PV cell circuit which consists of this current source driven by sunlight in parallel with a dual diode. There is a more complex model of PV systems are there, which is out of the scope of this particular lecture. So here we have different types of parameters that in a particular panel, if you want to buy one panel, you will have to buy from the market with respect to the watt peak value. So watt peak is generally what is the wattage, that is the power produced by that particular PV module when 1000 watt per meter square of solar radiation is available. So, however, that much range cannot be more much. I mean, that cannot be made available. But however, they some parts we may get some lower or some higher. So we have different types of parameters like open short circuit current, that is ISC, and the POC of that PV panel, by which we can take the different type of modeling of the PV cell. Shorting means this path is short and the current is measured, and VOC means this 2 points are open and the voltage is measured. So two parameters is the short circuit current and the open that is open circuit voltage. Two important parameters of PV are short circuit current and the open circuit voltage. So here you can see that I have told you this full sun means 1000 watt per meter square. This is the VI general VI characteristics of a PV cell. So this is the full sun. Full sun means it is 1000 watt per meter square radiation is available. So you can see that with the change in the radiation, the current of the short circuit, current of this particular panel changes. Okay. So this is half sun, that is 500 watt per meter square radiation. So we at 500 watt per meter square radiation, though the voltage change is very less, however there is a huge change in current than that of the full sun. So from cells to modules, so generally an individual cell produces only about 0.5 to 0.7 volt to 0.6 volt. So it is a rare application of using just a single cell. So we generally do not use a single cell to serve a particular load. However, we generally use modules, 12 volt modules and some 24 volt modules in order to put it into a particular application. So this is one cell. The cells are combined in series and parallel to form modules, and again the modules are solar PV modules are put in series and parallel to make PV array. So this is the combination of cells and parallel. This is VI characteristics of that one. So this is apart from the VI characteristics, we have also the power characteristics. Since the power of the PV panel that is plotted. So this is the peak power that we are getting at a particular solar rate. So what are the components? So in a particular, we want to design a particular solar photovoltaic system. Means we want to give the energy to the load. Then the different components are required apart from the solar panel. So the different components are inverter, controller, battery, load. So these are the components. So we can store energy in battery either, or we can store it into the grid. So if there is an excess energy that is generated apart from the load to be charged on the daytime, so that can be stored in the battery, or the excess energy can be put onto the grid. Solar panels that are available generally in various power ratings that we have, like 1 watt, 5 watt, 10 watt, 50 watt, 100 watt, 250 watt, 300 watt panels. So generally in the market we have the solar panel rating is given in peak watt or maximum power under the standard test condition. So the standard test condition is what? It is 1000 radiation, 1000 watt per meter square, or full sun, that is the radiation, that is the peak radiation that we have, and the solar panels are rated according to that. So what does that signify? That signifies that if we want to put it in the outdoor conditions and we want to give it to the load, that means we will not get the exact output that we are going to find. So for a 40 watt peak panel, the different classifications are VA, that is the maximum voltage that we can get, that is 18 volts, and the maximum current that we can get, that is 2.22 amps, and the maximum power that is we are getting at full sun, that is 40 watt peak. Similarly, we have other modules, higher panel, higher power of power panel ratings are there, like 250 watt peak panel. For that, we have the voltage that we have 30 volts, and the maximum current that we can get it from here is the 8.4 amps. So, taking the classifications of the different panels like this, we can design our serve a particular load. So the typical price that one will ask for is that typical price for the panel in small quantities comes with 25 rupees to 30 rupees per watt, which is equivalent to 0.3 to $0.38 per watt. Similarly, we have 100-watt stick panels. So again, there are again classification. One we will see in the market that there are different types of solar panels, like that of monocrystalline solar panels and the polycrystalline solar panels. So this is a monocrystalline solar panel made of monocrystalline silicon cells, and this is the typical polycrystalline or multicrystalline silicon cells or solar panels made of multicrystalline silicon cells. There are again another type of PV panels that are also used that are thin film material, that are made up of thin film material. So if the modules are connected like this, so this is the series connection is there. So in the series connection, the voltage takes increase, okay, and the current remains the same. However, in the parallel connection, the current is increased and the voltage remains the same. The solar panel efficiency. This efficiency is very low. However, it comes with 15% to 20%, and recent advanced research in the efficiency comes more than that, more than 20%. So amount of incoming light that is converted into electricity that is from that solar panel efficiency. The requirement for each one, we say that the requirement of a particular house is 1000 watts and corresponding to 50% efficiency. That is 150 watt per meter square. So the total panel area required is about 6.5 meter square of area that is required. So the area requirement also is a constant, like in the solar installing solar panels onto the rooftop. So there comes to the area requirement of the rooftop. So generally 1 kilowatt panel will need 72 square feet of region or area, and 2 kilowatt will need 144 square feet of area. So according to the requirement, also one will design the system onto their rooftop. Generally, the solar panel lifetime is very high, about 25 years, and after that starts to degrade. However, one can use up to 25 years with different types of operational and maintenance procedures. They can use it. The general battery we generally use is lead acid battery onto it. However, in different areas, we also are using different types of other like lithium and other sources of energy storage are there. So battery depth of discharge is also a factor in designing. The lead acid battery comes to 50%. However, the lithium ion battery is just a little bit more costly than that of the lead acid battery, but it comes to 80 to 90% of depth of this. So we have to consider that how different types of sources, different types of batteries can be converted, can be used in a particular solar off-grid system. So lead acid battery comes with 7 to 8 rupees per watt hour, and lithium ion battery starts with 13 to 16 rupees per watt hour of inverter is there. So we can also use inverter. The role of inverter is to extract maximum power from the panel, manage the battery, and convert DC power into the AC power for our AC load. Typical inverter rating comes with 1 kilo, 1 kVA and 2 kVA, 3 kVA, also 5 kVA. Efficiency of inverter varies from 80 to 90%, 90 to 95% for a good inverter. Cost of the inverter also comes with 4 to 8 watt, and also for good inverter it is 8 to 50 per watt. So different types of things are there. That is one. Another thing is that the charge controller, it is also used to extract the maximum power from the battery and manage battery and provide appropriate DC power to the appliance. Charge controller efficiency also varies from 80 to 85 to 95%, and also it comes with the cost of 3 to 8 rupees per watt. So this is a typical block diagram of a DC solar system where we load, DC power load is there, DC loads are there, and this is the charge controller that we are using. And to the from the charge controller, we connect the battery as well as the solar panel. So using these four components, we can install a DC home, so solar DC solar home system for our own home load. The DC solar home system is higher in efficiency, lower in cost, and also there are different types of non-component cost items, like in which the PV panel has to be mounted, like mounting structures are required, wires are required, some installation cost comes with it. However, though the initial cost is very high, we can generally use the solar panel system because the solar panel comes with the life of 25 years. We can design a particular system considering this, like this. If a tube light is there, we will consider the watt. If there is AC power, we will consider the watt as the number of appliances and the hours of usage. From that one, we will find out the load, that is the energy required per day, kilowatt hour per day. So if we can calculate that one, then we can also design our AC home system. And this is the AC home system, which comes with the inverter, and here is the battery, and also the panel that gives supply to the load. So general pricing will be around for a general load that I have shown here. It will come with a very low pricing, like it will come with the general. It is at par with the electricity consumption that we are doing in our day-to-day life. So it comes generally about 7 to 8 rupees per kilowatt hour of energy. So the cost of energy is very low, or it, as far as with that of the grid electricity, we can install our PV home system, and with the installation of that one, if we are encouraging the environment more pollution free, and we are serving to the nation as well as to the world for becoming more and more uh, mm, renewable energy pro energy serving load. Thank you all.